Okay, so another example of problem solving with the Venn diagrams. We're looking at example 6, page 313, and the case is this: in a class of 26 students, it is found that 10 study geography, 16 study history, and 4 study neither one. So the first question is, A, calculate the number of students who study both geography and history. And question B, find the probability that a randomly selected student studies exactly one of these two subjects. So we'll make a Venn diagram for this situation then. So this is our Venn diagram, and we have a circle for history and we have one for geography. And we could also say something about the number of elements in each set. And we could write this with this notation here, n, and then parentheses, h. We know that the number of students in the set called h for history is 16. We also know that the number of students in the geography set is 10. And then we know that there are 4 students who study neither one, and we also know that there are 26 students in the class, and that's what we've marked here. So the number of elements in the set U, the universal set, is 26. So now we want to look at our first question. Calculate the number of students who study both geography and history. So we know that the students who study both subjects would have to be inside this area here, but we don't know the number yet. We're going to find it. So we just mark that as X so far. We don't know what it is. Could we write a number in the history set? No, not yet, because we don't know exactly how many we should write here. I mean, we do know that within this whole circle, there are 16 history students. But they are divided between this set, this part of the sack here, and this part here, which we don't know. So what we need to do is we need to write 16 minus x. Because if you take 16 minus x, and then you add x, you're left with 16. So we know that there should be 16 altogether. And likewise, we can do the same for the geography box here. We know that there are 10 geography students. So we take the 10 that we know about, minus x. And if we take 10 minus x and then we add x, we get 10. And we know that there should be 10 geography students. And the last bit of information we should put in is that we know that there are, there are 4 students who study neither one. So we mark that with a 4 here. Okay? So our job now is to find the x value. And we know that, okay, well, if we add everything together here, if we take 16 minus x plus 10 minus x plus 4, we must have the same amount as we have in the entire universal set, so 26. And what we could do then is, minus x plus x, that just falls away, right? So we have 16 plus 10 plus 4 equals x plus 26. And I mean, if we subtract 26 from either side, let's see. I mean, this makes up 26, right? And this is 26 here, so we could remove that on either side. And we're left with x equals 4. Yeah, so we know that x equals 4. So, number of students who study both geography and history is 4. Now the B question. B, we are to find the probability that a randomly selected student studies exactly one of these two. So one of these two. And we want to find the number of students in this area here. What is 16 minus x? And we want to find the number of students here, 10 minus x. And now that we know that x is 4, we know that x is 4, so we could say that, okay, 16 minus x equals 16 minus 4 equals 12, and likewise 10 minus x equals 10 minus 4 equals 6. And so we know that the number of students who studies exactly one of these two subjects is 18. And what have we seen about probabilities before? We know that the probability of an event, so let's call this one geography or history, but not both. So the probability of that is going to be the number of students who fulfill this criteria. So that's 18. And we divide that by the number of students in the universal set, 26. And all right, yeah, sorry. Of course, what I meant to write was number of students in the set G or H divided by the number of students in the universal set, which is 18 divided by 26, which happens to be the same as, let's see, 9 divided by 13. And if you want, you can also write this as we round it. Sorry, we round it off to 0.692. But 9 over 13 is just as good an answer, and that's also approved in exams. And it's an exact answer, whereas this is an approximate answer. It's a rounded off answer. But probabilities always lie between 0 and 1. Between 0 and 1. Okay?